Simba, let me tell you something that my father told me. Look at the stars. The great kings of the past look down on us from those stars.
Really?
Not really. Spoiler alert, right? I was disappointed to hear it myself. But if we take a mental field trip back in time a few years, we can find out how everything got started. Or at least understand where we are now. About 13.8 billion years ago, our story begins in a quiet little neighborhood called Nothing. But don't worry, something big was about to happen. Although it cannot fully be explained, the universe began to get hot and dense in a centralized location. From this point, there was a great inflation, or Big Bang. Are you ready for it? Sorry you couldn't see it. The light doesn't exist yet. But it was awesome. What you couldn't see was that in microseconds, protons and electrons were formed that would later join up to make helium. With the amount of vast space created, the atoms were able to cool almost instantly, even though the universe was about the same temperature as our sun's core, and with about the same amount of pressure, it was able to fuse hydrogen into helium. Can you imagine how many balloon animals you could make with all of that helium? This fusion process generated photons of gamma radiation, but there was nowhere for it to go. It wasn't until about 380,000 years later that the universe was expanded and cooled down enough for the protons and electrons to bond. It was in this process that the first forms of light developed. The universe was already expanding exponentially, and gravity stopped being lazy and got to work. It really started pulling matter into smaller clusters, and these clusters became huge clouds of dust and gas called the nebula. The nebula collapsed on itself, creating a disk shape. Due to gravitational pull, the larger objects began to pull to the center, forming a star, and the smaller objects began to collect together as they spun around the center. These smaller pieces formed the planets, and the dust and the gases formed their moons. Except for Earth's moon. Something hit the Earth when it was in its early stages of development and knocked off some of the Earth that would soon form into the moon. But that wasn't the only thing that came from this event. It would also slow the Earth's rotation and knock it off of its axis, giving the seasons, which would become vital in the process of making life. Complex organic molecules began to form that were the foundation for life. These bacteria would later become more complex and form into other life forms we call cells. These cells would become the building blocks for life as we know it. Long after the birth of philosophy and science, in 1807, John Dalton discovered that matter could only be broken into discrete pieces called atoms. Up until now, we call this entire period atomic physics, and it will remain so until 1877 when J.J. Thomson discovered the electron. Up until now, the atom was just a pudding shape with electrons floating around. But in 1911, Ernest Rutherford expanded the idea and found that 99.97% of all of the atom's mass is concentrated in the nucleus. This was done by shooting an alpha particle through a sheet of gold to see if they would bounce off the gold atoms. It worked. But there was still one more discovery to be made. In 1913, Niels Bohr discovered spectral lines within the atom, and a planetary model was assumed. We now know the model's a little more complicated than that thanks to the Heisenberg's uncertainty principle that says that we cannot know an electron's exact position or speed at the same time. But who cares, right? These were all pretty insignificant discoveries in the grand scheme of things. Well, you're wrong. Physics has given us one more amazing tool in the discovery of our universe, the periodic table of elements. This table has all 118 elements used to create the world we know. With this information, we can see how quickly an element can form or how long it will take for an element to decay. We can tell not only how long something has been in the ground, but in the atmosphere as well. It was because of discoveries like this that in 1965, when Aaron Penzias and Robert Wilson discovered strange noises being picked up by the Bell Labs Hohn-Horn radio antenna, they were able to find out what they were actually hearing was one of the most important cosmological discoveries in history. It was the whisper of the cosmic microwave radiation from the Big Bang. Here, Arno explains cosmic microwave background radiation through the timeline of the universe.
He thought about a Big Bang source of the universe, realized that it would be very hot and therefore full of radiation, and as the universe expanded, that radiation would simply cool. And whereas it was extremely hot to start with, by now it would simply be microwaves. Now it's so cold that it would just be radio waves.
Because of this technology, we have another way of proving this theory. We can measure a change in the redshift galaxy spectrum lines, and are able to do the math in reverse to calculate the amount of time since it started. Now that our mental field trip is over, watch your step as you come back to reality. Now that you've educated yourself in physics, I hope you can ask yourself this question. If the world is such a unique place in the universe, why aren't we taking better care of it?